Okay, sir.
Is the screen visible now?
Yes, sir.
Okay, fine. Let me just see if recording is started. Yes. Okay, fine. Yesterday we had discussed templates and a little about standard template library. I had told you that standard template library consists of many algorithms and many generic data structures. So vector is one of those generic data structures. This is how we'll use it. First we'll declare. First we'll include its header file, and this is how we'll declare it. Since it is integer, the vector will be able to store integer values. Since it is generic, you can specify any data type here. It may be any inbuilt data type, or it may even be user-defined data type. Means you can even create a vector of objects of a class created by you. We have declared two vectors here, iv1, iv2, and then we have declared an iterator. I have told you yesterday that for traversing through the elements of the vector, there are two methods. One is direct, you can simply use a for loop, or you can traverse through the elements of a vector using an iterator as well. So when you declare a vector, its initial size and capacity. Size means how many elements are there in the vector. Capacity means how many maximum elements it can hold at a time. So initially it will be 0, 0. As you can see here, size and capacity are 0, 0. After that, we can reserve some space like we have done it here. We'll reserve space for 100 elements in this, but we are not inserting any element in the vector. Then you can see here, size is 0. Since there's no element inside the vector, we have not inserted any element, but its capacity is now 100 because we have reserved space for 100 elements in it. The next, how to insert values in a vector. We'll use a simple for loop. We'll try to insert 20 values into it using this function push back, and we are inserting value of I, which will keep changing. It will range from 0 to 19. It means we are inserting 20 values in the vector. So after inserting those 20 values, let us see what is the size and capacity. Once again, you can see it here. Size has become 20 because we have inserted 20 elements and its capacity is 100 only. Okay. Then I had told you yesterday also that there is the problem with array that if you have declared a larger array, say array of 100 elements, and but you are storing only 20 elements, then the size of the space for 80 element goes wasted, right? You cannot recover it. But in case of vectors, like in this case, we had defined its capacity to be 100, but we are storing only 20 elements in it. We can shrink it to fit equal to its size, right? We have only 20 characters. Why to store? Why to reserve space for 100 then? And so you can see it here. When we execute it, so after shrinking to fit, the size is 20 and capacity is also 20. So to print these values, I had told you that there are two methods. One is direct, another is through iterator. First of all, let us see what is the direct method. Within this, I have also included size and capacity of the vector. We'll be able to know whenever we'll try to print the elements. So this is the direct method. We'll simply write a for loop and use it just like an ordinary array, right? The vector can also be used just like an ordinary array. So this is the direct method. Second is through iterator. We'll declare an iterator, and using that iterator, which will iterate from the beginning of the vector to the end of the vector, we will print its value using pointer iterator itself. So these are the two methods. So we have called these two functions. Let us see the output then once again. Here it is. This is the first one is through direct method. Second one is through indirect method or through iterator. So this is how it works. Up to this point, if there's any problem, then let me know. Anybody? If any of you is having any problem up to this point, then let me know. Okay. then we can assign a vector to another vector. For example, till now we were using IV1 only. Suppose you want to assign vector 1 to vector 2, you will call the function for vector 2 dot assign. Then we need to specify the range. Like in this case, we have specified that from the beginning of vector 1 to the end of vector 1, copy all the elements to vector 2. After that, uh, let me remove this. For vector 2, it will show the values. Have a look. This is after assigning the values to vector 2. You can see contents of vector 1 and vector 2 are the same, right? And its capacity and size is also 20. So this is how we assign one vector to another. Next is, if we want to clear a vector, means we want to remove all the elements from a vector. Like here, I have called this function clear for vector v2. Its size and capacity. Let's see what will happen to its size and capacity. Here, you can see after removal, after clearing, size will become 0 because we have removed all the elements, but its capacity will remain 20. And then you'll be able to know through this Boolean function, you'll be able to know whether IV2 it contains some values or not. You will call the empty function. If it is true, it means vector is empty. If it is not true, it means vector is not empty. There may be some values lying in the vector. Okay. The next is inserting an element at a specified location. So here we will use the iterator which we had declared here. Here we had declared the iterator for this vector. So what we'll do, first of all, we'll find its mid begin plus size divided by 2. We'll find its medium point, midpoint, and at that midpoint, we are inserting a value. So we'll write insert location where the element is to be inserted and the element which is to be inserted. So after inserting this, see what will happen. I hope you remember that size and capacity of IV1 was 2020. I hope you remember this. Let me put all these other ones under comment so that it becomes easier to understand. I'll share the code with you. Okay, let's run it now. You can see here, size is 20, capacity is 20, but the moment you insert a new value here, the value has been inserted at the location, mid location. So its size will become 21 and its capacity will also become 21. This is how we insert element into it. So function is simple. We simply write insert, provide the location where the value is to be inserted, and 100. If you want to add some element to the end of the vector, then the function is push back, like here, push back. It will insert an element at the end of the vector. If you want to insert somewhere in between, then the function is insert. Similarly, if you want to remove an element from a vector, find out its mid once again, find out its mid and erase it from there. Here we had found the mid and then we had inserted an element at that location. Here again we are finding the mid and removing the element from there. Let's have a look. We had inserted 100 here. Its capacity was 20. Size and capacity was 20. Now we have removed that element from the list, from the vector, and its size and capacity will come down. It will become 20 again. So this is how we erase elements from it. Okay. Once again, let me put all these under comment so that we may be able to discuss the next thing. Next we have erase a set of values. For example, here, what we are doing, again, we are finding mid, right? After finding mid, storing it in iterator, we'll erase the elements. This is the starting point from where the elements are to be erased, and this specifies how many elements are to be erased, right? So let me just run it once. 0 to 19 were stored in the vector. So we are removing elements from the beginning of it, right? From the beginning, as you can see, first 10 elements have been removed and next 10 elements are stored, and its size and capacity also decreases accordingly. Okay, fine. Similarly, we can erase elements from end also, right? So it is specifying that from the midpoint up to the end of it, remove all the elements. If we run it again, you can see elements from midpoint onwards, they have been removed, right? 10 onwards, elements have been removed. So this is how we remove elements from the beginning or from the end. Okay. Then we have, so if we are to remove a range within the vector, we'll specify what is the beginning. Then second iterator will contain the end from beginning to the from the new beginning to the new end, or from the starting point to the end point. It will remove the elements. Like here, we are specifying that from 10th up to 15th, these elements should be removed. So let us see it again. As you can see, from 10 up to 15, elements have been removed, and then the remaining elements are displayed here. Okay, then something very important is how to resize the vector. So when you resize, for example, up to this point, the size of vector was 50. No, sorry, 20. We are resizing it to 50. It means its size will become 50, and automatically the new elements, which are basically initialized to 0, the new elements will be displayed. Similarly, second time we are further resizing it to 80, but this time the new elements will be initialized with 101. Let me show you. So you can see it here. 0 to 19 was already there. Its capacity was 20 initially. Then we increased this size to 50, and all those new elements were initialized to 0. Then we further increased this size to 80, and all those new elements were initialized with 101. So this is how we do it. We call resize function. What is the new size, and by what value the new elements are to be initialized. This is how we do it. Then we can swap the two vectors also. We can interchange the values of two vectors. So for this, one vector we already have IV1. So second vector I have created IV2, and in reverse order I have inserted the values. Right. First, let us check up to this point only. So this is the first value, first vector. This is the second vector where values are stored in reverse order, and then we call the swap function. You can call it either by IV1 or by IV2. If you're calling the swap function by IV1, then within the parameter you will pass the other vector. So after swapping, let us see what are the values we are displaying here. This is vector 1. Its values have been reversed because the reverse values are stored in vector V2. And in vector V2, we have got the values in sequence. This is how we reverse the elements. Similarly, if you want to find the value of some particular element within the vector, like here, we can see, we can get the front and last or the back values. So it is saying 0 and 19. So this is a simple example how to use vectors within STL. So if you have any problem at any point about vectors, then let me know. Otherwise, we'll move to the next topic. Yes, if there's any problem, let me know. Am I audible to all of you?
Yes, sir.
Yes, sir.
Okay. Any problem?
Can you
No,
provide
sir.
No,
the
sir.
problem?
Somebody was saying something. If somebody is having any problem, then let me know. Okay. Otherwise, we'll move to the next topic, that is exceptions. Any idea what is an exception? Yes. Any idea what is an exception? It is basically a runtime error. There are three types of errors. First is syntax, second is semantic, and third is exception. Syntax error means these are found at compile time, these are found at execution time, we can also call it runtime, and exceptions are also at runtime. Now, what is the difference between these two? Syntax error means there is problem in the grammar. For example, let me remove all this and we'll discuss it. Just a minute. I'll share the code with you after the class. Like here, if I write C out some hello and I'm not putting the semicolon there, it is a syntax error. Means there is an error in the grammar, right? So this is syntax error. Then what is semantic error? Semantic means there is some problem in the logic. For example, you have written a logic which contains some error. There is some problem in the logic itself. Then that is semantic error. What is the outcome of a semantic error? Your program will run, but it will not give you the expected output. You may be expecting something from your logic, but there is some problem in the logic, so you won't get what you are expecting. Exception is something different from semantic or runtime errors. Exception means something which you had not expected, right? Something which you had not anticipated that it may happen. For example, if you are trying to print some document and the printer is switched off, it will give you an error message that printer is switched off. Or if you are trying to read from a file which doesn't exist, it is again a exception. It is not a semantic error. You didn't check whether the file is there or not, and you straight away try to read from the file, then that is an exception. So we need to handle these exceptions. If an exception is not handled, then your program will abnormally terminate. For example, let me show you. Integer sum I is equal to 10 divided by 0. The most common exception is divide by 0 error. When I run it, see what will happen. It's saying divide by 0 or modulus by 0. You're trying to do that. Similarly, if I declare integer a is equal to 0, and then I try to use a here, let's run it again. Again, now this is again an exception. What has happened here? Your program has abnormally terminated with a message that integer division by 0, which is not possible because it is not defined. So to handle such situations, we need to handle these exceptions. There are three things involved in an exception handling mechanism. First is try, then throw, and then catch. The piece of code which may cause an exception should be put inside a try block, right? Let us take up an example of this. Written try, integer a, out, enter a positive. I am taking up a very, very simple example. Enter a positive value or positive integer. Be in C in A. If A is greater than 0, then C out valid value. If the value is greater than 0, then it is as we had expected, else write throw A. So try block is there. Within try block, we are throwing an exception, and outside the try block, there should be a catch statement. The type of exception we have thrown is A, which is integer. So we'll catch an integer exception. Out invalid value. Here, out writing reaching here. I told you that if exception is not handled, then program is abnormally terminated. Sometimes it will not even tell you the message. It will not convey you the message why program has been terminated, right? But in this case, if you are handling an exception, then it will quit the program very gracefully. Or it may even happen that it may ask you to rectify the error and continue execution of program. But if exception is not handled, program will abnormally terminate. So like in this case, let us run it. It is asking for a positive integer. If I enter 10, it will say it is a valid value and then reaching there. Okay, fine. Let's run it again. So if I am entering any positive value, it says it's a valid value, and whatever you want to do with that, you can do. And then it is reaching here, right? It is terminating normally. But if we enter any negative value, then it will say it is an invalid value, but still program continues to execute. It will not abnormally terminate, right? Because you are handling the exception. This is how it works. A very, very simple example of handling it. So three things are involved. First is try. The code which you expect may cause some kind of exception, put it in the try block. From within the try block, check if there is an exception, then throw it. The kind of exception that you will throw, it will be caught outside. Okay, let's continue with this. There may be any number of catch blocks, any number of throw statements within a try catch block or try catch mechanism. For example, here, even if it is a valid value, let me throw it. Okay, let me just throw this. Throw A. But if it is a wrong value, let me write throw invalid value. Entered. So there are two different types of throws we are doing. First is a valid value. Second, catch, character, pointer, string, or message, whatever you want to write. Cout, str, and then. So in first case, it is throwing integer kind of exception. In second case, it is throwing character pointer kind of exception. So let us see it. How is it working? When I enter 10, it will go to valid value. It will be caught here. And if I enter some invalid value, for example here, -1, then we are throwing a string or a character pointer kind of exception. If I run it one point at a time, let us see what happens. I'm executing it one statement at a time. So here it specifies where the control is. So it is executing this statement right now. It will ask for a value here. I have entered 10. Let's see, where has it gone to? It is here. So throw A is there because it is a valid value. We had entered 10. It has reached here. It is executing this catch block now and then reaching here, right? Similarly, if we enter an invalid value, let's see what will happen then. Again, I am running it one statement at a time. It is asking for a value here. I'm entering -1. And this time it is going to the else part and throwing character pointer kind of exception, which will be caught by the second cache block, and then it will print the appropriate message. This is how it works. Up to this point, is everything clear about exception handling? Yes. Up to this point, is everything clear about exception handling?
Yes, sir.
Yes, sir.
Yes, sir.
Any problem? If anybody is having any problem, then let me know. Okay, fine. Let us check your syllabus once. We are discussing exception handling. Okay, okay. Okay. Then there is a concept called catch all exceptions. This is something very important. Sometimes it happens that there are many types of exceptions, say 10 types of exception, you've been able to handle 3 or 4, then you can write a catch all block which will catch all other unhandled kind of exceptions. How to write it? Look at it very carefully. Catch within bracket 3 dots and then cout dot unhandled exception. Right? For example, have a look here. We are throwing integer exception. It will be caught by the first block. We are throwing the character pointer kind of exception. It will be handled by the second block. Suppose I am throwing here, I am throwing some other kind of exception, say 2.5, which is a double exception. Double is not handled here anywhere, right? So it will be caught by the catch all exception block. Let us see. If I enter a negative value, invalid value, will reach the third catch statement caught unhandled exception, because we are not handling double kind of exception, so it will go there. But there is something to be taken care of, that the catch all exception block should always be the last in the series of catch blocks. If I put it as the first, then this block will handle all the exceptions. As you can see, there's an error now. Handler is masked by default handler. So this is a default handler. If you will write it as the first catch handler, then no other catch handler will work. So it should always be the last in the series of catch blocks. Is this thing clear? Yes. Is it clear?
Yes, sir.
Okay. I want to finish your syllabus by Sunday. I want to have classes. I want to take classes on Saturday and Sunday as well. I hope there's no problem. Anybody? Any problem on classes?
No, sir.
Any problem if we have classes on Saturday and Sunday? Because I want to finish your syllabus by Sunday. Yes, anybody having any problem with classes
No,
on
sir.
Saturday? Okay, fine,
No,
No,
sir.
fine. If anybody is having any problem, you can convey me separately also. Otherwise, we'll finish your syllabus by Sunday. Okay, let's continue. uh, this exception handling part is clear to all of you? Yes. Then we can create class-based exceptions also. I have written my exception. created a very simple class with the character pointer that will contain the message and a constructor with the character pointer as its parameter and a display function which will display the message here. So int length is equal to str. How to copy the contents? Let me just show you. MSG is equal to new character length plus 1 and then string copy MSG message and from the new string. Okay, fine. Let us use this code itself. Okay, everything is fine. Here, what I do, look at the code here. First, look at the class which we have created. We have created a myException kind of class with the character pointer as a data member of the class for handling messages. Through the constructor, we'll copy the passed message to the character pointer and then we'll display it using the display function. Let us use the same code. If the value is valid, we'll simply throw integer kind of exception. But if the value is invalid, then we'll throw class kind of exception. Invalid value entered. You need to understand what we are doing here. So what it will do, I have written myException, which is name of our class, and then passed a parameter. It will create a temporary object of the class by passing this parameter to it. And here we'll handle it. myException me. Here we'll write me dot display. Run it once. Functions will not work here. String copy. We need to use the secure version of it. Okay, fine. So if I enter a positive integer, it will simply say valid value. Right? First exception handler will be called. If I enter some negative value, then what happened? Probably it could not be entered. Let me just try it once again. Okay. It causes problems sometimes. I'll explain the problem to you just a minute. Okay, fine. This is how we copy the message to our data member, that is character pointer. First, we'll get the length of the message. Then to message, we'll allocate memory equal to the length of the message plus 2. That is for storing the null value so that we may be able to terminate it. We'll copy the message to it and then set the last element to null so that the string is terminated. Though it should not be required when we are using string copy, but since it was giving problems, so we have used it. Okay. So when the value is valid, it is throwing an integer kind of exception. If the value is invalid, then it is throwing myException kind of exception. It is a class exception here, right? It will be caught here, and the message which we are passing here, it will be copied. Its constructor will be called. The message will be copied to the data member, and through display, we'll be able to display the message. You can see it here once again. If I enter -10, it is saying, oh, still some problem. Just a minute. -10. It's saying still some problem is there. Okay, no problem. I'll rectify it and then let you know what was the problem. Is this thing clear? How to use classes for handling exceptions? A very, very simple concept we have discussed here. Is it clear to all of you?
Yes, sir.
Okay, that's all for today. Tomorrow we'll continue with exception handling. We'll handle exceptions using inheritance also. And we are basically left with three topics, or rather two topics, files and STL. So in the next 3 days, we'll be covering the remaining part of exceptions, then file handling and the standard template library. Okay, that's all for today. Take care.
Thank you, sir. Okay.
Thank you, sir.